All right, so we're going to go ahead and start talking about the next lesson. You did get some of this in the previous video notes, but we're going to review it because I know it can be confusing. So we need to talk about function notation. Function notation is the way a function is written. It is meant to be a precise way of giving information about the function without a rather lengthy explanation. The most popular is to use f parentheses x, which reads as f of x. So we would call that f of x, where x is our input value and the equation would be considered our output. Traditionally, functions are referred to by single letter names such as f, g, h. You can use any letter, however, so notice f, g, h, s. We could say q of x. We don't also have to use x, so we could say q of r. That part doesn't really matter. Again, the ones that we typically try to avoid would be the letter O and I and E. Typically, we don't use those as variables. Function notation is another way of representing the y value as a function. So f of x is basically y. Obviously, x is going to be our x. Y may even be labeled as f of x axis. So we could label it like this, f comma f of x or x comma y. The notation f, where x goes to y, tells us that the function name is f and its ordered pairs are formed by the elements x of the set x and the element y from the set y. So x is mapped to y. Now, when we look at this box, all of these say the same thing. You will likely never see this form, so let's just ignore it for now. But y equals 3x plus 2 is the same thing as f of x equals 3x plus 2. So this is important to remember. They're the same thing. When we come to evaluating, we're going to talk about substitution. And again, I know we talked about this somewhat in the last lesson, but we might as well review. So substitution, you are trying to figure out at a given input. So in this case, they tell us what happens at 4. Notice over here it's x and here it's 4. So what we're going to do is substitute any x's with 4. So notice they changed the x to a 4. They changed the x to a 4, and then we're going to solve. So 3 times 4 is 12, and 12 minus 5 equals 7. So we could write it as the ordered pair, 4 comma 7, or we could just say it solves to 7. There's a lot of different ways we could do it, but notice it still becomes xy. Again, this time they said b equals 3. So still we're substituting. Anywhere you see a b, we're going to change it out for that -3, and they did that. So here. And -3 times -3 gives me 9, which is times 3, minus 2 times 3 gives me -6 plus 1. This will change to a nice fat plus sign. So we get 27 plus 6 plus 1, which gives me 34. And we could say that it's -3 comma 34 as well. And I feel like we probably don't need to go over another example here. Actually, we do. Let's do this one. So this says plug in g of, or use 2w. So anywhere we see an x, this time we're going to plug in 2w. And we're going to solve. So 2 squared, this becomes 2 squared and w squared. And 2 times 2 gives us 4w. So we would have, what is 2 squared? We would have 4w squared minus 4w, and I left that plus 1 out on accident. And that would be our answer again. Number 4 is going to be the same thing. We just take it and plug it in. And number 5, they're giving it to us backwards. They said that f of k, or f of x, equals 8. So what is k? Or what is x? So this time we're going to set the equation equal to x and solve. Function notation. Again, we just kind of talked about it. F is the name of the function. X is the variable. And this means the variable at the function. So let's go ahead and do some examples. 7x minus 1, and we need to figure out what happens at x equals -2. So x equals -2 is what this is saying over here. So now if I know what x is, I can plug it in. So I would have f at -2 equaling 7 times -2 minus 1. 7 times -2 gives me -14 minus 1, which gives me -15. So we could say f at -2 equals 15, or we could say 2, 15. Let's try the next one. So again, this is saying that x equals -5, which means anywhere I see an x, I'm going to put that -5 in. So I'll have g at -5 equals -5 squared minus 4. That gives me 25 minus 4, which is 21. So we could say g of -5 equals 21, or we could say -5, 21. On the last ones, I don't believe I put a graph on here. So let's go ahead and pull up a graph, and we can talk about how to identify it from a graph. So I've just come up with kind of a random equation, x squared plus 7x minus 2, and this would be the graph for that. Now, if I told you I wanted to find, can I write on this? Nope. If I wanted to find f at 6, that means that we need to go over to where x equals 6. And then we need to either look up or down. In this case, we need to go way up. Still following that 6 line. Until our graph crosses, which I believe would be right here, which I can't really get on it, at 6. And it looks like the answer for y would be 76. I can do the same thing. Let's pick a smaller number this time. Let's go with f at 0. So if I go over and up 0, I want to go to where x equals 0. I look up and down. In this case, I look down to y equals -2. So our ordered pair would be 0, -2. Now, if I told you f of x equals 0, that means we need to go where y equals 0. We would go over to 0, and it would be right here at like 0.275, which typically that's not going to be something we do. Let's say that f of x equals -6. So we need to go to where y equals -6 and go over. And it's a really small number, -0.625. So let's go to where f of x equals +6. So we're going to go all the way up to 6 because it's f of x, not f of 6. So f of x means we go up and down. We're going to look, and where do we cross? We cross at 6 or at 1. So our ordered pair would be 1, 6. If I said f at 1, we would go over to 1 and then up. I want to go ahead and talk about the vertical line test again. So the vertical line test is a test to see if something is a function. So what I'm going to do is I'm going to make a red line. Doesn't really need to be that big, does it? That's okay. Can I not pick it up? There it is. So what I'm going to do is take this red line and see vertically, do I ever cross the same point twice? Here I do. Notice. When I put it there, I cross here and here at the same time. And since it is vertically aligned, that means that this is not a function. But if I do the same thing on the next one, you'll notice I'm never going to cross that vertical line. I'm never going to cross twice, which means it is a function. Let's pick one that's a little bit easier to identify. So like here, you can see again, I cross here and here at the same time, which means it is not a function. And when we are looking at ordered pairs, as I mentioned yesterday, we want, or when Monday, we want to look at our x term. Our x will tell us if it is a function. Do I have the same number written twice? I have -2, 2, 3, 4, 5. I do not have a repeated number, so this means it is a function. So again, we're going to look at our x terms. And I notice I have 2 -1s. Since they do not solve to the same answer, this is -1, 0, -1, 7. That means it is not a function. And lastly, when we're looking at mapping, again, we're looking at our x terms. They will not have repeated numbers. But notice this 6 has 2 lines coming off of it, which means it will be 6, 3 and 6, 5, which then tells us it is not a function. And again, I want to talk about domain and range. So we remember domain is x, range is y. So what I want to do is go through and find all of my x values and write them for domain. When I do that, I need to make sure that I go smallest to biggest number. So when I look at -5, -4, -2, 0, 1, I want to make sure that I write them in order. And we're going to use that squiggly bracket. Let's see if I can, there, that looks a little bit better. So smallest to biggest, -5, -4, -2, 0, 1. We got lucky on that one and everything was in order. Now when I write my range, I'm going to again highlight because it helps me see which ones I want. We need to do the same thing. Write them in order from smallest to largest. So my smallest is going to be -1. And then my next number is 1. And then 3. And then technically it says 4, 4. But I do not need to write the second 4 as long as the number is written once, we're good. When it comes over to putting ordered pairs in a table, it's going to be just, I suggest putting your domain, your x values in order. So -5, and I'm reading directly from here because we already did it, -5, -4, -2, 0, 1. And now match up your y values. So -5 goes with 4. -4 goes with -1. -2 and 0, or I'm sorry, 2 and 1, 0 and 4, 1 and 3. When we're mapping, we need to align them like we did for domain and range originally. X goes first, Y goes second. So again, we're going to put them in order from smallest to largest. So -5, -4, -2, 0, 1. And then we're going to rewrite our domain numbers. So -1, 3, 4. And now I'm just going to literally map them together. So draw a line from -5 to 4. Draw a line from -4 to -1. Draw a line from -2 to +1. From 0 to 4. And from 1 to 3. It is supposed to look messy and confusing. If it looks messy and confusing, you probably did it correct. Last step is to talk about graphing. Hopefully you remember how to graph. So we're going to go to, I like using the chart, the table to graph. So I'm going to go over 5, -1, 2, 3, 4, 5. and up 1, 2, 3, 4. Over 4 and down 1. Over 2 and up 1. Over 0, up 1, 2, 3, 4. And 1, comma 3. Now we're not going to do all of this second one, but I do want to point out when I'm looking at my domain, I notice, again, there are 2 -3s, which means this will not be a function. And the way we're going to write it is similar to the last one, smallest to biggest. So let's move on to identifying domain and range from a graph. For this one, we're going to have to use our inequalities. So remember, domain is x, which is left to right. So when I look left, this arrow tells me that it goes forever. And when I look right, this arrow tells me it goes forever. So our domain never ends. We will touch any x value, which means we're going to write x is all real numbers, which, as my face-to-face kids said, this is x, funny looking e, funny looking r. Now, when we talk about range, remember we're talking about up and down. So does my graph ever stop going down? It does, right here at -2. What about up? Well, this side tells me it goes up forever, and this one is going up forever. So it just has a stopping point going down. The way I would advise setting this up is 2 less than symbols. The smallest number goes on the left, and the biggest number, which would be infinity, goes on the right. Do I actually hit the point -2? Yes. So we're going to put an equal sign under there. And technically, you do not need to tell me that it goes to infinity. So we can erase that bit. And we would be left with this. So let's look at the circle. I'm going to go ahead and label all these. This is -3. This is 3, 3, -3. So let's talk about left and right. My graph makes a hard stop at 3 and -3. So like I said, we're going to put x in the center. Oops, I just realized that should be a y, not an x. So we put x in the center, and we're going to say it is less than. And we said there's a hard stop at 3, so we're going to put that equal sign. What is the smallest number? -3. And the biggest one is +3. So again, we're going to do the same thing with range. We're going to use y this time, though, because range is y. In the farthest down, the smallest number is going to be -3, and it does touch. And up top, the biggest number is 3, and it does touch. Number 3, notice it is a never-ending straight line. This is a linear line, which means x and y can be any number we want. They are all real numbers because it never stops going up, it never stops going down, it never stops going left, and it never stops going right. So it can be any number under the sun. Coming back to our domain again, does our graph ever stop going left? No. And it never stops going right. So this one is, again, going to be any real number. But our range, we notice it stops here. It never gets taller, which means that's going to be 1, 2, 3, 4, 5. And again, I'm going to put y in the center. I'm going to put my less than symbols. Since 5 is the biggest number, it's going to go in the big spot. Technically, we could write negative infinity here, but we really don't need to. And it does hit 5, so we can say equal.